here we've got a pretty horrible rational function, and we're just going to find the form of the partial fraction decomposition and not actually solve for all of the unknowns, because that would be just a ton of algebra, and it's just not really worth it beyond just illustrating what our form should be. So we've got some factors here. It's already completely factored for us. We have this x factor here raised to the 3. So x by itself is a linear factor, and it's repeated 3 times. That means that we're going to have 3 terms in our partial fraction decomposition with a denominator of x, but we work our way up to the exponent. Okay, and of course the numerator for a linear factor is just a constant, so we have a, b, and c there. Okay, so that's for this first one here. Okay. For this next one, x squared plus x plus 1. This is an irreducible quadratic. If you're not sure if it's irreducible, you can always try to find zeros. And if you end up with complex zeros with I in there, then you know that it's irreducible. So with an irreducible quadratic, we know that we've got that in our denominator. And the numerator now is not just a constant, it's something times x plus something. That was really kind of messy. Let's try that again. So dx plus e, okay? Because that's an irreducible quadratic. And then our last factor here, we've got an x squared plus 2, which also is an irreducible quadratic. And so we know that we're going to have that in the denominator, but you'll notice that it has an exponent of 3 on it. So we also need to work our way up to that exponent. So we have it squared and we have it cubed. And again, because it is an irreducible quadratic, the numerator will look like this. So fx plus g, hx plus I, jx plus k. Okay. So that's the form of the partial fraction decomposition. Okay. The irreducible quadratic factors get a numerator that has something times x plus something, and we always work our way up to the exponent on the factor. Now, at this point, you see that solving this would be a horrible, horrible, horrible process, because we'd have to, expand all this crazy stuff out, and it would be, you'd get a system of equations, 11 equations and 11 unknowns, because there's 11 constants here, and that's just not fun. So generally, we would use a computer algebra system to solve something like this.